question for the first speaker regarding the high capacity of 4,000 tons for the diameter 1.1 meter. The concrete strength is 55 megapascal. So I roughly calculate the ratio of the stress in the pipe is around 75% of the concrete exit time. So is it okay? That is the first question. And the second question is that what is the lateral load transfer system from the superstructure to the substructure to the ground? Thank you.
两个问题问刚刚的第一位讲者，刚说的这个桩里面这个是4000吨的，然后呢是采用 C55的这个混凝土的一个强度的标准，这样的话最终这个75%
of the concrete strength.
所以这个最终是就是75%的这个混凝土的一个强度。
指的是哪个阶段
？Can you specify the 75%?
I just divide the 4,000 by the cross-sectional area of the pipe. It will equate to the 420 kilogram per square centimeter compared to the 550 kilogram per square meter of the concrete strength. So it's about 75%. I think it's very high.
他说就是这个4000吨的，然后呢，这个 C55的这个强度，然后进行这样一个计算之后，然后达到这个是75%，是他说就是跟您确认一下是。
还不止吧，就是算下来的话，混凝土的话估计能达到占部分呢，大约是80%-90%左右，钢筋所占的比例比较少。
Well, the concrete strength should be 80 to 90%, and the rest is for the rebounds.
Sorry, can you just clarify? The 4,000 tons, that means ultimate load. The service load they are using, I think, is very much less than that.
Yeah, it is shown in one slide.
ELS or
No, the 4,000 tons, that one is ultimate load basically. Yeah, ultimate load. Yeah, their working load is less, very much 2,000, isn't it? Yeah, very much less.
4000吨是这个最极限的、最多的一个量。
4000吨呢，我们试下来，还没有破坏，但是砖顶的位移度比较大，因为我们这个砖110米长嘛，本身的砖身的压缩面积的话，估计都占到整个面积的70-80%左右，70-80%。所以没有继续再往下压了。就是从这个砖土来说的话，它承载力是达到至少4000吨以上，有加载量。但是受限于这个砖身的这个混凝土强度的控制，整个它会是双控嘛，所以没必要再继续往下加。
So basically 4,000 tons is the ultimate tonnage of it.
And the second question is the lateral load transfer.
The vertical load.
Superstructure to the ground. What is the system?
他说的是这个桩的这个垂直的这个承载力的一个转移是怎么转到它旁边的这个地面上？
垂直转就是通过铆砖那个，你说加载方式是吧
？Excuse me, I want to clarify what your question is about the contribution of the lateral loads to the overall foundation capacity. I'm not quite sure.
My question is the wind from the superstructure or the seismic from the superstructure. How do you transfer this load to the soil by the connection between the mat foundation and the pile, and let the pile take all the load, or you use the lateral bearing stress of the soil around the basement, diaphragm wall or something.
Okay, I think all the lateral loads will be transferred firstly to the lateral resisting system, and the lateral resisting system will transfer to all the foundations. Firstly the basement, and finally all the piles. Actually, for all the shear capacity of the foundation piles, commonly is significantly higher than all the lateral loads. So this is the first way to take all the lateral loads. Secondly, due to the contact between the basement walls and surrounding soils, commonly we in the design we will specify that all the soils has to be compacted, constructed to make sure that actually they can also transfer some kind of horizontal roads. And thirdly, as we mentioned, Mr. Xu mentioned that there is the excavation protection pit. The excavation protection pit. Actually, they will not be removed after the construction of the building, but they do can also contribute to resisting the lateral loads. So I think that there are three parts, but commonly, we will not consider the last two contributions.
The question is regarding you design use a pile rock foundation, is that right?
Yeah, pile rock foundation.
If you use a pile rock foundation, it means you excavated approximately about 5 basements. So before they have what's called ground loading, and you move it up. So your foundation may be smaller because you reduce the weight. Is that right?
You
when
mean
you design the wall piling.
Mm-hmm.
So the example, totally you have 100,000 tons, the building weight, and you excavate 5 basements, example 40,000 tons. Move it to soil.
Yeah,
So
there will
reduce.
be a positive settlement. You mean that?
Yeah, yeah.
Positive settlement.
And so you design 100,000 minus 40,000, so 60,000 tons is for the wall pile. Is that you are doing for that or different?
这个是考虑了那个就是地下水开挖期间那个土的重量，就是契合作用。然后我们还考虑了那个沉压水，就是沉压水对它的一个有利的浮力作用。沉压水。
Yes, so basically they have considered the weight of the soils and the taking out of the foundation, and at the same time they have also considered the floating out from the water.
Oh yeah, okay.
I think we have to consider different aspects. Firstly, the overall building weight. Secondly, for the pile design. Firstly, building weight. Secondly, the raft self weight. The self weight of the raft. And then, as Ms. Xu said, we have soil, the soil stratum, soil layer below the maybe it has water with very high pressure. That will also contribute to the design of the pile because it can reduce the weight. And also you mentioned about the soils excavated in the basement height. I think that also has to be considered firstly for the pile design for a permanent situation, and also because we applied actually especially for the podium basement we use a top-down construction method. So for the design of all the the basement, we have to consider the soils during the height of the basement depths.
But I heard, I don't know, I heard the thickness of the slab, the basement only 1 meter. For how many floors?
The raft.
Yes.
The raft thickness finally it's 6.3 meters.
Oh, 6.3.
6.3.
I just.
Just ask Korean, just curious, what is the lateral deflection of the observations that under the 10 years returns window?
For lateral deflection, commonly we check the deflection on the wing loading of 50 years return period, not 10 years return period. So actually we for satisfy the code specification, we only have to check the storage drift, not the top deflection. We consider storage drift. The storage drift ratio limit is 1/500. For the building top deflection, I think it's also maybe 1/500 to the overall building height. Maybe some 1 to 2 meters. So yeah.